When you first walk over to Innotec, you want to check the pressure. Right now it's 2 times 10 to the minus 7. That usually means that it's been pumping for a long time. Somebody closed the bell jar and started pumping. If it is above 5 times 10 to the minus 7, you're going to check the time that's right up here. And if it's recently used, that's okay to have a higher pressure. If it had a 5-hour and you still had high pressure, then you have a pump problem. You're going to check the temperature of your cryo. Right now it has 16 Kelvin in the front, but in the back of the system is an onboard display and it's 12 Kelvin. So the cryo pump's okay at this time to continue using. The main power button is on, but the light for off is also on. So we have no power control applied yet. Here we have crystal health, 94%, no thickness, no power, no rate, because we are not depositing. The West gauge is the temperature inside your bell jar. Has to be below 40. This is the only time we ask you to look at the temperature. When you start depositing, temperatures will rise somewhat, but we really don't care at that point. So, checking the logbook, logging in, you're going to press the stop button. Everything looks like a go. So we stop. You change the screen to a runtime screen. And then we're going to press system ready, pump only. That would be F6. The manual tells you each key you're supposed to press. F6, there's always a delay, so don't touch it again because you're actually going to be telling it to pump down. This actually takes about 5 minutes. We're going to wait for the atmosphere ready light to come on. Once I see this light, I'm going to wait 1 additional minute. We have a clock on the table that you can set, or you can actually go on the wall and use the second hand. 1 additional minute. It is venting right now. We have Innotec mirror that we're going to be checking inside. We have a supply drawer. Inside the supply drawer we have extra crystals that you can change. We have equipment out of service. We have a calculator so that you can calculate your dep rate. The rotation of your planetary is around 20 RPMs. You don't want to do anything faster than a 5-minute dep when you're doing thicker depositions. If you only have 50 angstroms, 100 angstroms, then you just want to use a slow dep rate. You don't have to worry about the 5-minute. Under the table, we have some clean shutters that you can change. We have some dirty shutters that are starting to peel. You take them out and replace it with a clean shutter. You bag them. The new ones come with a double wrap, so you can take one of the wraps and bag it so we don't distribute particulates all over. Atmosphere light is on. You have decompression in the bell jar. It takes 1 additional minute. I started the clock. When we are done, we'll go ahead and lift the bell jar. We have 1 up button, 2 down buttons for hand safety. Almost. We're going to turn the empty sign to in use. Everything's a go. Make sure your viewport is closed so that you don't sputter metal. Turn off your timer. With one button, we're going to tap up, make sure it's vented. It's vented, bring it all the way up. You take the bell jar all the way up because you have to do an inspection at this point. So you're going to be looking for peeling, anything that could contaminate your wafer or your starter source. So I have peeling here. So once you spot the different areas that have metal peeling, you're going to also look underneath the planetary. You're going to check all your wafers to make sure that they're good to go. Otherwise, you're going to change them out. Never touch wafers with your hands. Always use tweezers. This is a vacuum system. You have to keep it clean. Right here I have a mirror. So with the mirror, this is the only one you're going to touch with your hands. You're going to look underneath the shutter to make sure it's clean. If in doubt, you're going to remove that shutter. Hard places, you can look under here. This is your crystal. There's been some peeling there, but it looks like they vacuumed it up. Doesn't look bad. I'm going to check the wall. There's a little bit right here. Okay, so inside here's your thermocouple. This is your thermocouple that's telling you the temperature of the inside the chamber. This is your crystal. This is what you're going to change out if it gets below 75% healthy. I'm going to remove the shutter just to show you it's really easy. You're going to unscrew it. It looks clean. The mirror said it looked clean. If it was dirty, you would replace it with the clean shutters under the table. You would leave. The shutter has a pin and a hole. There's a pin right here that's going to go in the hole. This screw goes in there, and then there's a pin, and then you can screw back on, and you're good to go. Make sure this opening is in front. Ready? I'm going to open the shutter, and I have to come back to the video screen controller. That's VSC. I hit manual. My cursor's sitting here at filament. I want to go and open the shutter, F1. This up-down screen moves my cursor. This up-down arrow. Change that one. Toggle is a command, F2. So it says open, but there was a long delay before it opened, so you have to be very careful. Jim's worked on it, but sometimes it just doesn't work. I'm going to close it. I'm going to try it again and see if I'm having trouble. So if that shutter doesn't open, you're not going to see a dep rate, and that would be something you're going to check if you think, why am I getting a dep rate? Make sure that shutter opens. So right now we're sitting on C2. That's a 25 cc. So I'm going to check for cleanliness, and I'm going to check to make sure I don't have a buildup. And you want to make sure because they've already damaged the front with the E-beam. Okay. So now I'm going to check each pocket. I'm going to move my cursor to crucible. Down arrows, you're going to move the cursor to crucible select. You're going to toggle, and this is where you go over there. And the first time you toggle, it goes all the way around to home. C2 is home. It stops on C2. I just fill to make sure that I don't have a buildup. Oops, touching the wrong place. I have a little bit of a buildup here. All you would do is get your chisel. And you would remove any buildup. This allows the starter source to fit correctly in the pocket. Did you see that? Okay. Now I'm going to check C3. It's going to rotate. I'm checking for, if I was going to use C3, I'd clean up that pocket. I'm going to check C4. If anybody's using silver, they need to always clean the pocket when they're done because it'll coat it white. So when you clean a pocket, I'm going to use C4, you're going to use the chisel. And the chisel, you never use your chisel in here or up there. It's only going to be used in this area. This is copper, a copper hearth. So once you see copper, that's good. So don't worry, we're going to vacuum this area up. Try not to get anything down where the filament gun is. Try not to move your two poles. Okay, so now we'll turn on the vacuum to vacuum this up. What you want to do is cut a piece in the center of a clean wipe. Remember, this is a vacuum system and needs to be kept clean. So once I clean up my crucible, I just vacuum it up. Okay, once I'm done, I'm going to close the shutter to protect that crucible because I'm going to start vacuuming on top. So coming here, I'm going to bring this down to shutter 1. Toggle as a command, F2, close the shutter. When your wipe is dirty, you have several that you cut and you can just remove. And toss the dirty one. This plate is to keep the heat from the cryo pump that's underneath in here. You want to go in here? It's to keep the debris from going into the cryo. You can vacuum this plate. It gets a lot of metal. And then you just place it back in position There's a second shield right below this plate, also protecting the cryo. Once we're done, we can actually load your wafers once you've vacuumed and cleaned your crucible. I'm going to open the shutter. I'm also going to change gloves because I've done some cleaning and they're dirty before I touch my metals. Wafers, because we don't want them to contaminate what we just cleaned up. So I'm checking the top, because you can use rough side or shiny side for a dummy wafer. So this dummy wafer looks like it's peeling. So I'm going to remove it. And then I'll go underneath and check the other side. So most of them look pretty good. So underneath I'll have some dummy wafers. Hopefully they're clean, they're good dummy wafers. You never stack back-to-back dummies. When you load a dummy versus a real wafer, you're going to put the primary any place but straight down. That's telling us this is a dummy. The uniformity is better on the outer ring. There is a difference. The reason why we have a uniformity problem is this arm that holds the crystal in your thermometer or thermocouple. When you rotate counterclockwise, it blocks the vapor. So until it comes forward, does it start to see vapor again. So you'll always have a uniformity problem. I'm going to use tie. This is just to help bring the pressure down so we're not waiting so long. I'm going to measure tie. Tie is 19.8. You're going to log that in the book, 19.8. If you look at the chart, titanium minimum weight is 18.9. So we can add a few pellets just so that we don't bring the weight below the minimum. Now I have 20.20 grams, 20.20 grams of titanium. So I'm going to pick up this. You want to make sure he's sitting flat, and he's not sitting flat. This is keeping him from sitting flat. So I've got to move him around.
Did it split them up?
Huh?
Did it split them up?
No, I'm okay. So the dimple is telling me he was sitting here, like in this position. So that might be the best position he's going to sit. But he doesn't feel good. He doesn't feel like he's sitting nice and flat. He doesn't feel like it's at the bottom. And this can have a lot of effect on your rate. But we're not going to open him. Titanium is normally the easiest metal to use. Titanium is oval when it hardens, so you never have a flat surface. So the pieces never stay in the center. Very seldom can you get it to sit. I'm not happy with the way it's sitting in here. But if it doesn't, you don't get your pieces, make sure the pieces are sitting in the front. My E-beam can focus towards the front, but it does not go far in the back area. You should always be adding pellets to your starter sources so the weights don't get this low. Unfortunately, either they're afraid to add pellets or they're just in a hurry. So I have tie. You want to make sure that I can rotate without jamming. I'm going to rotate with my arrow. I'm going to send it up. On this chart, we're going to do silicon and germanium goes in crucible 1. So I have to we're in crucible 4, rotate. It's going to go to C5. Toggle. C6. C1. So now I can put in the germanium. Germanium is what you're trying to avoid, is this peak getting too high where you can't rotate. So the art of this is cooling down the source very slowly. Okay, I'm going to weigh it. Now you don't have to. Zero out. I need, that level is very low. With the beaker, you can zero the weight. You can add the starter source, and then you can add your pellets. Sometimes it's a little easier. So it's 46.85. 46.85. And this is germanium. And if you look at your weight, germanium weight when we buy it brand new is something like 37. And 22 is the minimum weight, and I've got 46. Wow, I got bigger, but it looks awfully thin. Maybe I won't put so much in, but it looks very low. Germanium doesn't weigh very much. Lightweight stuff. That, we're going to put him in. With the arrow keys, we go down to shutter 1, F2 is the command, close. Okay, I can lower the bell jar. 2 hands, 2 down buttons. In the right place? Yeah. Center shields? Okay. Make sure you don't nothing's come loose and you're going to be bending metal. Listen for sounds. Don't release till it's all the way down. Front of the bell jar hits first, and then it takes a second for the back end to drop or close. Release. Take a look. Make sure the back end isn't sitting up. You don't want to see any light in the back. If it looks good, we're going to go ahead and start pumping with the roughing pump. Okay, this is the first time your vacuum gauge is going to start to work when I go return F1. I'm going to press vent F6. It's actually going to stop venting. We're waiting for pump only to pop up. Once pump only, F5. Remember, the run sheet tells you every button you should press. Once the pump starts, remember there's always a delay, count to 10. The light should go off within 10 seconds. It's not a big deal if it takes 13, 15, but that light goes off. If it doesn't, you're going to hit stop before you burn up the pump. you can get a hold of maintenance. The crossover takes us about 7 minutes and 40 seconds. So right now we have the roughing pump, and then the cryo pump will take over. And you have to wait 1 hour before you can start depositing. It is the titanium we're going to use to help bring down the pressure. Otherwise, if you don't want, you want to make sure there's no titanium, then you're going to wait at least 2 hours. So the crossover is 7 minutes and 40 plus or minus a minute. It's not a big deal as long as it crosses over. But you cannot leave this machine until it crosses over. You want to make sure that that cryo takes over and you're not going to burn up the roughing pump by walking away and not attending to it. We have 8 parts coming out that are dirty, and we're going to exchange them with clean. Each part is double bagged, so you want to save 1 bag because you're going to put the dirty part in the bag. So this is the platen. I'm going to number 1. Two. It's going to be right to left. 3 and 4. You have to make alignment marks for the user to see, to align the chimney with the platen. So I'm going to go center, center, then I'm going to try to draw a straight line. And there we have 1. That's an alignment mark right in the center. It's 2.
Did you pour dirty? Want me to change it out?
Yes, please.
You have one?
And 1 more. Okay, so this is the platen. Then you're going to put the dirty one away. We'll take it out and send it for clean. And then the chimneys have a mark also. So you take the chimney, but the chimney, you got to test them to make sure how they sit. Cathode. 1 piece of the anode. Cathode. You have the other piece of the anode. So you're going to put the cathodes together, line them up, the holes, always holding it from the center. They're snug, some of them more than others. Find the alignment holes. For the chimney, it has to sit flat. See this one? It's sitting flat. This side does not fit flat, so you always have to test them before you do the mark. So this side fits flat. So this is the way that it goes. So you always have to check them. Each of these chimneys are different. So I'm going to find the seam. It's easy to make a line on the seam. I can see the seam. And then what I'll do is make a long line because they have to be able to see it. Short lines they won't see. So now you have a line on the chimney. So you'll get the other chimney and you're going to make sure you get the right side to make the mark. And some chimneys both sides fit, so it's not going to matter. But that one didn't. So you'll find once in a while one that doesn't fit on both sides. I found the seam. I'll put this along the seam so I can draw my line. Again, it has to be a long line so they can see it over the plate. So there's your other seam. All right. And that's the only things that you have to mark, the platen and the two chimneys. On the cathode, you want to get your dirty cathodes. They're sitting inside. So you pick up your dirty parts, set them there. There's 4 screws. You don't lose your screws. You're going to take them out off this cathode. There's 4. And there's 4. And these are going out for clean along with those. And then you're going to put the 4 screws into your cathode. Don't lose your screws because they're vacuum screws and hard to come by. Don't give me a screw. Let maintenance know so they can replace it with the right height. Okay, so we're going to pick up the new anodes. Anode, when we close up, put the cathode, set them on top. Get your chimney. You can set them down. Pick up your platen that's been numbered. You're going to set it in. So your alignment mark has to be able to, from the end to the chimney. So that's how you're going to, if this one's aligned, then this one's aligned. And you're sitting right under your targets. Take a look, make sure you didn't leave anything behind. We're done. We can close up. Clean parts. So when we're completely done, you're going to close the Innotec. You're going to turn over the empty sign. Make sure everything's off. All lights are off. You're pumping down. Green start is on. Remember that you cannot vent or pump the system down unless it's enabled. We did make pressure. Tell me when. So we're going to, it's 1.2 times 10 to the minus 6. We're going to go ahead and try to getter and bring the pressure down with titanium. We're going to hit stop. The page changes to runtime screen. We're going to go to manual, F3. Right now the cursor is sitting on filament. We're toggling. We're going to turn that on. We're going to move the cursor all the way to planetary. Turn planetary on. Right now it's sitting on germanium. I don't want germanium. I want C4, titanium. So I'm going to toggle. So when I toggle, you're going to wait a while because it's actually going home to C2. It will make the rotation. Once it hits C2, then I can toggle. C3, you have to wait till you see the number because it's not going to go if you hit it 10 times. C4. So we are on C4. Planetary's on. Okay. So my crystal health is 94. Reset is lit. I'm going to press abort, reset, start. I get a list comes up of all the programs we have, and I'm looking for titanium. Titanium with this down up arrow. I'm going to number 5. Select cursors on each side of titanium. To select it, you hit start, then abort, then reset, and then manual. Right here's the list of metals and the number. So if you're running hafnium, it says it's 25, so you're going to go to 25. That's the program. Okay. So it should say titanium spelled out and the symbol Ti. Now I'm going to the power controller. So main power is on the on. I'm going to press the on button here. Once I press the on button, on high voltage source 1, I'm going to press the reset. The reset light is lit. It's always lit. Hit it again. And these 7 lights have to come on. If one does not come on, you're not going to be able to run the machine. So now what we're going to do is make sure we're going to start this remote. So this toggle is a 3-way toggle. It is remote, local, and hand. So you go down to the middle, the local. You press the source 1 on button. You flip it up, remote. And on high voltage, you press the high voltage on button. So here you just give it a few seconds. I'm going to unlock my pot for the high voltage, and you want minus 10 plus 0.00. So I'm going to go minus 10.00. Get close, and then lock the pot. Okay, here I want to make sure I'm in the center on the lateral. 2 green buttons, 2 green lights. Sorry, 2 green lights. Okay, so we're somewhere in the center once I start bringing the power. We want to make sure we're in a manual mode. Here on the viewport, want to make sure that the mark is, this is all the way open for the polarized window. Clockwise all the way up means the shutter's sitting out of my way, I can see. Film, we want to advance the film just a quarter turn to make sure it's clean film so we can see through when I start. Then we're going to go to the logbook and see titanium. You're going to check 3 users that use titanium. Because you don't know if one is a beginner. So Ti, they used 2.8%, 2.8%, 2.5%. So somewhere around there we're going to use Ti. 2.5. So now we're going to, with this remote, we have power up, power down, abort. This abort is the same as this abort. Either one. If you see something going haywire, you're going to hit the board. So now what we're going to do is we're going to tap 0.1. Power, percentage, 0.2. You don't want to start, if you press the button all the way down, it's just going to shoot power, and you're going to probably damage something. 0.6, 0.7, 0.8, 0.9. When you start bringing power, you need to look into your polarized window to see the E-beam. But we really don't have an E-beam right now until I see this DC amps 0.04 change to 0.05. Once that changes, then I should be able to see an E-beam through my polarized window. It usually takes 2.1 to 2.2% power before that happens. So once this switches, then I'll be able to see an E-beam. Now I have 2%. It says to do about 2% every 20 seconds. Don't go any faster. 2.1, almost. We have not seen, there it is. It's slightly switched. You saw a little arc there, 2.05. Now I can see, once that DC amp changes, I should be able to see an E-beam. If you look in here, okay, so now what I got to do is I got to move the E-beam and heat the whole source up. That's only one. As I move the E-beam, I'm going to start heating and melting pellets. It's very bright, so I'm going to counter. You can do counterclockwise or clockwise to dim your E-beam so you can get a better look. I have 2.4% power. When you're mounting, you can actually go into spiral or triangle. It just gives you a wider E-beam so you can go closer to an edge. So now when you look in here, you have a lot of, the whole source is nice and hot. I can actually give you more light if you need it, or I can dim that for you. So it doesn't look like it changed anything here, but what I've noticed is not when I bring it up, is when I bring it down that I'll see. So now I'm bringing power all the way down. I don't need the tie anymore. It's done its job. The no that everybody is writing is, you can circle it. No, I don't own this tie. S&F owns this tie. 94% was my crystal health when I started. Crucible, it was sitting in C4. Power, I don't have to have any of that because it was just for bringing pressure down. Here we go. So then I have my germanium, right? My crystal health is still 94%. I'm sitting in C1. A lot of times you need to write that. You should write your, because some of these can take, except for silicon germanium, can take. So I've got pressure down. I'm going to rotate to C1. So I'm going to toggle. C5, C6, C1. Okay, so now I'm ready to bring up the germanium. So I know I want somewhere, but what's very important with silicon or germanium is when you start to power up, I already know that I can't see an E-beam until this DC amps changes to 0.5. 0.05. So I don't even look in here until that changes because it's dark. But I do want to go slow. Once I see an E-beam, I'm going to start moving this E-beam faster because what happens with silicon and germanium, once I move it out of one spot, it cools down the other spot really quick. So what I'm going to try to do is get this whole source heated, and I really have to go much slower in bringing power and bringing power down. We will not bring this power down when we're fast, when we're cooling off, turning down power. 1.3, 1.4. The other metal that tends to blow up a lot and it's your expensive metal is platinum. And the only thing I can think of is they're bringing power too fast. All of these usually is power too fast. 1.9%, 2%. Hold up. It's still black inside. I can't see a thing. I want to make sure this polarized window mark is straight up. 2.2. Okay. I should see E-beam. I don't. Okay, I'm going to hit one more time. Okay, there I've got a glimpse. So now you can see just a small amount of E-beam. I'm going to put this in spiral because I want to bring the power slow. And I'm going to start moving. Power up, 2.4. I had a lot of pellets in here and big ones, so I'm going to have to melt those also. But remember, this will get hot pretty fast. I don't have a lot of light until, there's not a lot of light for me to see until I get it nice and hot. So if you look in here, you can see the back wall with a little bit of light. You want to see? Put the two greens under the center. Because the level is so low, center is not center with your eyes anymore. Because the metal height is too thin. So this will get you closer to the center than your eyes. And you can tell by a lot of my starter sources where the dimples are. So we're ready, 2.7. I don't know how fast, but you always want to hold your remote in your hand. We're going to, with the up-down buttons, we're going to bring the cursor down to shutter 1. Okay. We're going to open. Toggle is your command. It says I have nothing. I'm going to 2.8. We're going to be here longer than we think. Okay? looking, we have 2.1% dep rate. We're using 3.7% power. We've deposited 71, 72, 73 angstroms. Dep rate has dropped a little, so all you do is tap, make this 3.8. So we want to keep it somewhere around 2. We're not. It's going to yo-yo a little bit up down, but it shouldn't go too far. 3.9.
Can you keep this one sometimes here? Yeah, that's good.
So our target is 1,000 angstroms. So especially with this metal that we're using, we don't want to bring power all the way down. We're going to close the shutter and slowly bring power down so that we don't create a peak. 4% power. I'm just trying to keep it up to 2 angstroms per second. As it rotates, you want your wafers to see the same dep rate to get a good uniformity. See, I'm not going to change much unless this rate drops a little or goes too high, then I'm going to increase it. So we're 1/4. I click 4.1%, just get the dep rate at 2 or close to 2. We're going to be at 500, we're halfway. So it's behaving itself. It's doing what it's supposed to do. A lot of the problems is the way you set your sources in their pockets, and you have clean pockets. Otherwise, you're going to run into a lot of problems. Advance the film. Advance the film. Turn the film like that, a little bit. Okay.
Just a quarter turn.
Yeah. So what it's doing, it's coating that film clockwise. Did you see it clear up? A 100 more. We're going to toggle off, and all it's going to do is close the shutter, and you're going to lose this and this. And this one, we don't want to bring the power 40, oops, down. We're going to take it slow. This metal does not want to cool, and you want to move it also because we don't want that peak to grow.
Increase the sweep?
We could, yes, I went to the, oh, I didn't go. So now I'm just going to move it so it doesn't sit in one spot and grow upward. Okay, I'm losing it anyway. Once I can't control the sweep. I can't, it's gone. The E-beam is not on my, and it's starting to cool, but I'll still bring it down slow. This is how you do silicon and germanium. Down button. Power percent is 1.1%. Press abort. I'm going to log my, oh, you did already? Okay. Alrighty, so now what we have to do is turn things off. So we're going to, I'll go back into manual. Your source 1 off. your high voltage off. If I was going to do another metal, I could go and rotate to my second metal, but I'm not. And then I'm going to go ahead and turn off filament. Wait, well, I'll do the filament since I said it first. I'm also going to turn off the planetary. The planetary button is the longest one. Whenever you touch the F keys, it takes forever. So just this happens to be the longest one. It's off. Then I'm going to main power off. Okay, then I'm going to reset. I'm going to hit return. I'm going to go to pump only to cool off my sources before I vent. You need to go 5 minutes for most sources, 10 minutes for silicon and germanium. So we have a timer that's sitting right here. We're going to wait 10 minutes because we just used germanium. When 10 minutes is up, I'll be pressing the stop button. When I press the stop button, you're going to have more options on the right side. Minutes. Press stop. You're going to hit vent F6. You're going to wait for your atmosphere light plus 1 additional minute after you see your atmosphere light, and then we'll be able to raise the bell jar. Okay, so we're waiting for atmosphere light. If you notice, the temperature is above 40, but we really don't care when we're using it. We only care when we walk to the machine. If it's higher than 40, then something's wrong when somebody has left it. This temperature has to rise somewhere around 280 before it shuts the cryos. Tungsten will do this. Tungsten will get that temperature up, so you have to be careful. You need more power, but it'll heat up inside the chamber really hot. So when people want to do a tungsten, ask them, what thickness do they want.
There's the atmospheric light.
Okay, now we wait 1 additional minute. You should see decompression along the base of your bell jar, a gap, but we still have to wait 1 additional because you'll actually feel when you lift it, you'll hear it kind of pop and you're pulling on that O-ring. You don't want to pull on the O-ring. Some people say they can feel the end too, but we're going to tap 1 finger to bring it up, 2 for safety to bring it down. We had one of our pellets pop out. So the first thing you want to do is remove your wafers before you start touching anything else to get them into a safe place. sure you put your dummies back. Doesn't matter whether it's rough side or polished side, they're dummies. With your flat, any place but down. Okay. Now we're going to open the shutter and remove our metal. So here you're going to go to the manual F3. You're going to move your cursor to shutter 1. You're going to toggle to open. So to remove that, you can see that I have a tiny peak. Small little peak, you don't want it too large. You're going to clear the scale. You're going to measure 4341. 4341 grams. You're going to put this in your jar. This silicon and germanium go in a different location because people have to get told how to use it. We're going to go back and rotate. First time I vent, it's going to go home to C2. Toggle C3. Toggle C4. I'm going to go ahead and pick up my I'm going to weigh the titanium, 1994. Put it in my container, 1994. Okay. If you did a good job cleaning prior to using, most of the time you don't have to do anything else. You're going to check, make sure everything is good. I'm going to close the shutter. I want to make sure that I'm not peeling under my shutter. Okay, under the shutter looks good. You always want to check before you close up. 2 buttons to bring it down. Front comes down first, then back, release. I'm going to go and return F1. F6 to stop venting. You're waiting for pump only to pop up. It takes, anytime you touch them, it takes a while for them to respond. You don't start counting until you hear the roughing pump itself. There's always a delay. Okay, now you count. Went off within 10 seconds.
Good job.
You cannot leave here until it crosses over, and then you can just make sure your logbook is filled out. If you have any problems, you're going to note it. Number of wafers, we did 2. Number of pellets added for the tie, I had 8. For the germanium, we had 4. Did we vacuum? Yes, we did. So you can circle yes, you can check X, yes, or you can put an X. Change crystal. No, we did not change the crystal. Did you check under the shutter? Yes, we did. Did we replace the shutter? No, we did not. Our thickness is 1 1004 angstroms.